Welcome. This is the first part of solving quadratics by factoring. Some of the most important materials are going to be presented in this unit, so please take good notes and pay close attention. So before we start factoring, let's talk about multiplying binomials. We have a binomial on the left, we have a binomial on the right. Binomial meaning two terms per. Now you're probably used to seeing this, and when you multiply it, use that whole FOIL concept. First, outside, inside, last. I'm not a big fan of that, simply because it only works with a binomial and a binomial. But we'll be multiplying binomials with trinomials and trinomials with trinomials and so forth. So I want you to think of it a little bit differently, because FOIL fails if it's outside of a binomial times a binomial. So we'll start with the first term here, the x, and really what we're going to be doing is we're just going to be distributing the x and multiplying it with both terms in the other binomial. So we'll just call that x squared minus 5x. And then we're going to distribute this negative 3 to both terms in that second binomial. So we're going to say negative 3 times x, which is negative 3x, and negative 3 times negative 5, which gives us positive 15. When we simplify or combine our like terms, we're left with x squared minus 8x plus 15. So we've multiplied it together by distributing the first term and the second term of the first binomial with the second binomial. So the general process with this is we're left with a trinomial. If you look at that previous example, we're left with a trinomial, and the b term is basically we get it by multiplying the second terms of both binomials, adding them together, and so that gives us the b term. And c essentially is when we multiply those together. Okay, we multiplied the m with the m, and that gives us the c term. So if you look at that process, that's generally what's happening. But we're going to be doing this process kind of in a backwards fashion. We're going to be factoring it. So we'll be starting off with a trinomial, and we're going to end up with two binomials that we're multiplying together. Okay. Simple analogy would be, okay, I have 10. I'm factoring 10. What two things multiply to get 10? Oh, 5 times 2. Okay, except we're doing it with a trinomial and trying to break it down to its components in that case. So let me clarify what I'm talking about. In this first example, I have a trinomial. So I want to figure out what times what gives me this trinomial. Now I'm going to use a method called cross multiplication, or the Xbox method. I like this method because it's fast, it's easy, and generally most students I talk to enjoy this method the most. If you have another method that you really like and that you're already used to, then I suggest you use that method. Go with what you're comfortable with. But I'm got to stick with one, so I'm going to stick with just this one method. And it takes a little practice, but in time you can be factoring just real quick, real easy. So let's see what we have here. Here's how this works. I'm going to look at the first term here, and I'm going to ask myself, well, what times what gives me x squared? Well, this one's pretty easy. That's just going to be x and x, and I'm just going to write it vertically like that. And then I'm going to ask myself, well, what times what gives me 48? And I can say, well, let's see, 6 and 8. So at this stage, I'm going to cross multiply. This is why it's called cross multiplication, or Xbox. But I'm going to say 8x times 8. That's going to give me 8x. And if I say 6 times x, that's going to give me 6x. And what I'm checking to see is if I add these two terms together, do they give me this middle term, 14x? And sure enough, they do. It gives me 14x. It works out. You can do that mentally, or you can write it down on paper. So basically what this tells me is that this is going to be my first binomial, and this is going to be my second binomial. I can rewrite this as, oh, well, this factors to x plus 6 times x plus 8. And if you multiply those back together, you will end up with this trinomial. Okay? I suggest that you verify that yourself. Don't take my word for it. Let's take a look at another one real quick. Now it's pretty easy, especially with these x squareds up front. So I'm going to take the same approach. I'm going to say, okay, well, what times what gives me x squared? X and x. And then I'm going to look at this -5 here. I'm going to say, well, what times what gives me -5? So I could try, let's say, -5 and -1, or rather +1. That will work. So when I multiply this, -5, so I'm going to cross multiply. I'll say, okay, x times 1, which is 1x, or just x, and x times -5, which gives me -5x. Well, do they add together to give me 9x? No. Okay, so that's not right. So I got to try something else. And I would think about it, and it's like, well, what else could be it? What else could do it? And it turns out that even if I were to say -1 and +5, and I change this, it won't work. So we're going to run into cases where we cannot factor this. So that will happen from time to time. So simply, for something that cannot be factored, we can write prime. Okay, so we will address those at a later date, but we can write prime or cannot, more accurately, cannot be factored. We'll discuss the prime business at a later date. Okay, we'll just say cannot be factored for right now. Okay, now there are also special patterns that you need to be aware of. The most important pattern is the difference of two squares. So basically it's a binomial. The first term is squared, the second term is squared, and very, very important, the middle term is a subtraction sign, and it must be, which simply means that, oh, well, then I can factor that to a plus b times a minus b. Okay, you really need to know that one. So the example here I give is like, oh, if I have x squared minus 4, well, x is a perfect square. That's square root of x squared is x, and 4 is a perfect square. Square root of 4 is 2. Okay, so here's 2 and here's 2, and there is, again, very importantly, there's a subtraction sign. So make sure that when you write your two binomials, one's minus and one's plus. You multiply those together, and it will give you the original binomial. The other two you can still factor using the cross multiplication or whatever method you want to, but it is very, very, very handy to have these ones memorized. The general idea here is that the first term is a perfect square, and the last term is a perfect square. Okay, and the middle term is doubling the square root of the first term and the square root of the second term. So like if you look at this example here, I have x squared. So I ask myself, is x squared a perfect square? Yes, it is. And then I say, oh, well, is 9 a perfect square? Yes, it is. That's 3 times 3. So, and then the middle term is at 2 times a times b. X is the a term. Well, the square root of x is square root of x squared is x, and the square root of 9 is 3. Okay, so this is my a squared, that's my b squared, and this is going to be my 2ab. Okay, that's going to be 2 times x times 3, which is equal to 6x. So it works out. The signs are going to be either plus plus, which in this case it simply factors to x plus 3 squared, which can also be written as x plus 3, let me erase this, times x plus 3. But it's just more shorthand to write x plus 3 squared. Or it could be minus and plus. Okay, so the second term is always plus. If that's the case, if it's minus and plus, the other pattern is still the same, then it's going to be, you know, our A term minus our B term, and then squared. Let's look at some examples real quick. So, all right, so I look at A and I say, oh, wait, it's a binomial, so maybe it's a difference of squares. Maybe it's one of the special products. So I would say, okay, well, is the first term a perfect square? Yes, it is. M squared comes down to M. Is the second term a perfect square? And yes, it is. That's like saying 11 squared. Okay, so we check last. Well, is the middle term is the sign a subtraction sign? And yes, it is. So this takes no work. Once we just go through that little checklist, we would just say, oh, well, then this is going to be M plus 11 times M minus 11. Okay, and we're done. Let's go down here. Let's take a look at this one. If I have r squared plus 14r plus 49, okay, I want to check to see if it's a special product. Now again, you can factor this normally, but I want to emphasize special products right now. So I say, okay, well, is this first term a perfect square? Yes, it is. R times r. Is this one a perfect square? Yes, it is. That's 7 squared. And then is this one 2 times a times b? Okay, so the square root of r squared is just r, and the square root of 7 squared is, or the square root rather of 49 is just 7. So 2 times 7 times r. Well, 2 times 7 is 14, and then r. So it checks out. And since this is a plus and a plus, I could write this as r plus 7 times r plus 7, or more simply r plus 7 squared. And I box that in, and I'm done. Okay. Go ahead and try to do C on your own. See if you can see how that one works. See if it does work. I'll pause it in 3, 2, 1. So I did a little check here. First term is obviously a perfect square. 144 is a perfect square. That's 12 squared. So I say A times B, or double A times B. So 2 times 12 times P. Well, that's going to give me 24 P. So it works. So I could just simply write this one as either P minus, because it's minus and plus, P minus 12 times P minus 12, or more simply P minus 12 squared. Box that in. Okay, so those are the special products. Okay, now you're going to see this type of question. It says, what are the roots of the equation? Or another way of saying is solve. Finding the roots is solving. Or find the zeros. Okay, would be another way to phrase it. They're all synonymous. There are slight differences. We'll go into that at a later date. So let's go ahead and check to see if this is a special product. So the first term is a perfect square. Okay, the second term is not a perfect square. Okay, so it's not a special product. So I'm just going to go ahead and just start my factoring thing. So that's what times what gives me x squared? Well, x times x. Now I got a negative 42, and so I'm going to try, well, I could try negative 6 and positive 7, okay? And I'm going to cross multiply that. So that would give me 7x plus negative 6x, and does that give me negative 1x? No, it gives me positive 1x. Okay, I'm close. It just means I probably need to change the signs. So this is going to probably be a positive 6, and that's going to be a negative 7x. Okay, so let's try that. And so that's going to be 6x minus 7x, which gives me negative 1x, or just negative x, our middle term. So right here, is my first binomial, and here's my second binomial. All right, so let's write that down. That's going to be x plus 6 times x minus 7 equals 0. Now notice this is equal to something. It's equal to 0, and that's important, that it has to be equal to 0. Okay? If it's not, we have to set it equal to 0. Now, we ask ourselves, okay, we need to solve this. In other words, we need to figure out what x is. The whole point of this, or one of the points of the factoring, is being able to figure out, hey, well, what's x, man? What do we get for 6? What do we get for x? So, if we're saying something times something is equal to 0, that means one of those somethings has to equal 0. This one could be 0 times this. Okay, 0 times x minus 7 will give you 0. Or x plus 6 times, if this was 0, would give me 0. So either one of these could be 0, which means that I probably have a couple different solutions here. So then I have to ask myself, well, what's going to make x plus 6 equal to 0? So what I do is we're going to break this apart. I'm going to say x plus 6 is equal to 0. And over here I'm going to say x minus 7 is equal to 0. Okay, so we're going to look for these zeros. Well, this one's pretty simple. Just subtract 6. So x is equal to negative 6. Will make sense. Negative 6 plus 6 is 0. Here I'm going to add 7, and x would equal positive 7. So here's how you write your answer. Because you have more than one value for x, we're going to use our set notation. So I'm going to say x is equal to negative 6, comma, 7. And that's the value of x. It's actually 2 solutions. So there you go. That's our first part of factoring. We'll go into, we'll add a little bit more to factoring next.